more proofs. I'm going to go over a few more, and then we got a worksheet on proofs. So, some of them are set up where there's just some missing stuff for you. The first few that we'll do. So, here's the picture. They give us two things, and they also marked it in the picture. Sometimes they don't do that. Sometimes they leave those lines out. So we know that EF is congruent to GH, and FG and HE are congruent. So they started off with the given and the other given. So remember, the whole idea is you got to figure out ASA, SSS, SAS, whichever one proves that the two triangles are congruent. If we just looked at this picture, you know why it's congruent?
SSS.
SSS. So I know this is going to be the final reason why they're congruent. So there's only one other thing in there. They said that GE is congruent to GE. Shared side, right? So anyone remember what the actual reason is? Reflexive. And if you put in shared side or same side, that would be correct too. So that's about as easy of a proof that there would be. Except for the next one. This one right here, we're going to write a two-column proof. We have our statements, reason. It starts off giving us NP equals QN equals RS equals TR. So we could put that in there. All of that is given. So what that actually gives us is two sets of sides, right? This side and this side, this side and this side. So this gives us two sides there. Then they tell us PQ is the ST. Oops. That's given. That gives us another side. So this one gave us two sides. This one gives us another side. So we have enough now. We can put the prove in there. So remember, the prove always goes last, whatever they ask you to prove. Because of SSS. So that's the absolute easiest because they gave you everything. Okay, this one. I should move over here. Okay, so it's given to us that AB is congruent to CD. So this equals that. And then it's also given that those two lines are parallel. So that means this line is parallel to that one. We're trying to prove triangle ABC is congruent to triangle CDA. So we can start off with our givens. AB is congruent to CD, given, and there is a side. Then the other given doesn't give us a side or an angle, but it does give us some information that we can figure out a side or angle. What do we know since these two lines are, alternate interior angles. Almost every time in these pictures, parallel lines are going to give you alternate interior angles. And they were nice enough to put a 1 and a 2 in there for you. So you could just say angle 1 is congruent to angle 2 because alternate interior angles are congruent. So there's an angle. Then we know one other thing. Shared side. AC equals AC. So again, you could put shared side or reflexive. So there's another side. So remember, they don't have to be in the order. You could put angle side there, whatever. It doesn't matter what order they're in the proof, as long as you have all three things. Once you have all three things, you put your proof in there. And the reason is side, angle, side, side, angle, side. Okay, a couple more. We gotta do the bisect one and a midpoint one. Okay, so the two givens are that PQ bisects angle SPT. And that SP is congruent to TP. So, there, that gave us a side. Now, what else do you know is true in here, Aries?
Angle SPQ.
Yep.
Yeah, SPQ is equivalent to QPT.
Angle SPQ is congruent to angle QPT. And why do we know that they're congruent?
Because line PQ bisects.
Right. All you could put is that's the definition of bisect. It told us up here it's bisected, so that's the definition of bisect. Bisect means cut it in half. So there we know an angle. And then all we need is show one more thing. Reflexive. PQ equals PQ. Reflexive or shared side. So there's a side. So now that I got the three things in there, put your proof statement in. And that reason is side, angle, side. Side, angle, side. SAS. So if they ever have something's bisected in there, you know they're going to be equal, whether it's an angle that's bisected or a side that's bisected. You would put that they're equal to each other, and you just say that's definition of bisect. Okay, then a midpoint. They have quite a few of these midpoints in here. So in this one, they give us that AC is congruent to BC, given. They say that M is the midpoint of AB, given. So far they gave us one side. So, since M is the midpoint, what can you say is true? AM has to equal MB, because midpoint means it cuts it in half. So AM is congruent to MB. Anytime they say something's a midpoint, you're gonna find two things are equal to each other. That's definition of midpoint. So there's a side. And then there's one other thing we know is true. Reflexive, they have a lot of those in there. CM is congruent to CM. Reflexive. So again, there's the third side, so we have it side, side, side. Triangle ACM is congruent to triangle BCM. Side, side, side. Okay. Okay, so here they give us two things. FH is parallel to LK and GF is congruent to GL. This gives us a side. So FH is parallel to KL. That doesn't mean they're congruent, just means they're parallel. And then GF is congruent to GL. So right now I only have one thing in there. So what else could I do? Vertical angles. Right there. Angle FGH is congruent to angle KGL because vertical angles are congruent. And again, parallel lines, what do you got to look for? Alternate interior. And this one you got a choice. This one equals this one, or you could do these two because they're alternate interior too. Whichever one you choose changes what your answer will be though, because right now it's why are they congruent? Angle, angle, side. So if I do that one, angle H is congruent to angle K because alternate interior angles are congruent. There I've got my three things, so I put my prove in. Because of angle, angle, side. I could have did this proof another way. Sometimes there's more than one way. If I wouldn't have did these two interior angles, if I would have changed it to these two, angle F is congruent to angle L, that changes, it's still two angles in a side, but now it's angle, side, angle. So either way would be correct. Okay? So we got a worksheet. One half the proofs are partially done for you, and the other half you got to do